All right, everybody, we're going to be looking at some basic math of working with series and parallel. So to do that, we're going to start with a quick summary. So series is when you have a battery and you have, in a sense, two in a row. The current has to go through both of them. And so if it has to go through both of them, the current will be the same as it goes through both. Okay, so let's say this is 2 amps. So current, the measurement is amps. It's how quickly the charge goes past it. Voltage, a way to think about voltage is like pressure. And so batteries will apply pressure. And then as they go across resistors, they will lose that energy. And so their potential will drop. All right, so let's make some fake numbers here. 10 ohms and 20 ohms. And so the unit for resistance is ohms. It's almost really looking at how resistive it is to current going through it. So I have one equation. It's called Ohm's Law, V equals IR. Okay, so what I can do is I can look at the V equal. Let's change color so you know what's going on here. I can look at the V equals IR for this single resistor. So its current is 2, his resistance is 10. So the voltage drop is what we call it, is 20 volts. So between here and here, it changes 20 volts. Now I could do the same for this guy down here, V equals IR. So V equals I. So the current is the same through both of them. His resistance is 20. So the voltage drop is 40. Notice these aren't the same. Here it dropped 20, and here it dropped 40. So altogether it dropped 60 volts. And what Kirchhoff, is a guy named Kirchhoff's loop rules that we use, he saw and he came with the idea of like whatever energy gets put into the circuit has to come out of it. So if you have a battery giving it a potential, giving it a voltage, that as it goes across these resistors, it dumps energy out into the environment or the system or to do something. And so if it drops 60 volts, that means that the battery had to apply 60 volts or motivate or produce or give pressure to 60 volts. So notice what happened here. This was 20 volts. This was 40 volts. What does the voltage do in a series? Well, the voltage in series adds up. And so that's different because the current is the same. Now, what was the evidence for why that was true? So when we did the lab with the light bulbs, we had 2 bulbs in a row, we saw that they had the same brightness, meaning the current that goes through one of the bulbs continues through the other bulb. So in series, it just keeps going through. Picture like a pipe with water flowing through it. If it flows through at a certain speed at one spot, it keeps flowing through at the same speed down further. Okay, so now we're going to talk about parallel. Parallel is when I have a resistor and then I have another resistor. Okay, and this is where it gets a little more interesting. Let's do the same thing. Let's say I have 10 ohms and 20 ohms. Okay, and let's say my battery is let's do 100 volts. Okay, big bad battery. And so here's the problem. I'm going to draw a little circle up here. At this little red circle, what happens is the current splits. It doesn't have to split evenly, but it splits. And as it splits, some goes one way, some goes another. Well, more of the current is going to go down the path of the 10 because it's easier. Less is going down the 20 because it's harder. So here's the key to this. In parallel, the thing that's the same is the voltage. The voltage is the same. So if this is 100 volts here, that means this is 100 volts on each of these. If I think about your house, right? You have all of these circuits, you have all of your light bulbs up on the ceiling, and if one of them goes out, it's not like the house turns off. Every one of them has their own connection to the battery. And so this 100 volts is going to be on each of these. Your house is at 110 to 120. And so it's going to be the same for both. So now let's solve V equals IR for this one. So 100 equals I times 10 ohms. So I get a current of 10 amps. This one I do V equals IR of 100, and the current I don't know, but the resistance is 20. So here I get a current of 5 amps. So here is 5 amps. Here is 10 amps. Did the same amount of current go to each of them? No. Now, if 10 goes that way and 5 goes that way, how much was before this junction? Well, I had to have 15 amps before they split up, because current is physically moving charge. You're talking about electrons, and so they split up at that moment. And so what does the current do in parallel? The current splits and recombines. And so the current splits and recombines in parallel, but the voltages will be the same. Okay, we're going to apply those ideas now. So let's do some damage. You ready? So what it is on this handout, I'm only asking you to do half of them. But this is very important that you do this, just because you will see these types of problems on MCATs, on SAT subject tests. You'll see them in AP Physics C. It'll just be assumed that you'll have exposure to them as you go to your next steps. So I want to make sure you have exposure now. Okay. So this is 12 volts. First up, is it series or is it parallel? So answer that one in your head real quick. This is parallel, because the current splits. Anytime the current splits, it's a parallel path. Anytime they have their own connection back to the battery, it's a parallel. So we got 12 volts. So what is the same? What is the same for parallel? Voltage, or potential difference, is sometimes we'll call it that. So if that's 12 volts, this is 12 volts, and they're both going to be 12 volts. Now look at this. If I do V equals IR for this path, I got 12 equals I times 3. I get a current of 4 amps. Well, on this side, I do V equals IR. So I get 12 volts equals I times 8. That V is going to be confusing if I leave it. So I get a current of 12 over 8, which is 1.5. Okay? Notice the currents are not the same. But what does the current do for parallel? It splits and recombines. So at this blue dot up here, right there, that current splits. Well, if I got 4 amps going here and 1.5 amps going here, what's my total? My total is 5.5 amps, because it splits and recombines. This is another question. It seems tricky. What's my total voltage? Total voltage is 12. I have a lot of students every year who'll say 36 because I added them up. No. The potential difference, the voltage on the battery, is 12 volts. That's all it is. It's just 12 volts. It just happens to be that they all are the same. All right. You know what I'm going to ask. Series or parallel? You got it. This is a series. So series, what is the same in series? Current. What do I know about voltage or potential? Is that it adds up. So what it is I have a current right here of 0.4 passing through here. So I can say right here, I can say V equals IR. Well, my current is 0.4, my resistance is 5, so I get a potential difference, a voltage of 2. I can do the same for the middle guy. So the current is 0.4. It's the same. So 6. So I get 2.4. And down here I get V equals IR. So the current is 0.4. And the resistance is 20. And so I get 8 volts. Well, it drops 2, it drops 2.4, and it drops 8. So what did the battery have to do initially. If it drops across each of these, as energy is pushed out, well, what does that mean the battery did? Well, it did 2 plus 2.4 plus 8, so that's 10, that's 12.4 volts. So it applied 12.4 volts of pressure to the system and then dropped across each of them. Well, what's the current? I think this is good. The next one, what's the total current? Well, a lot of students will say 0.4 plus 0.4. No, watch this. If the current here is 0.4, the current here is 0.4, current here is 0.4, current here's, it's always 0.4 is always the same throughout. And that comes back from the lab that you did on FET, where we saw bulb A, B, and C all have the same brightness because the current just continues through them. Same here, but here's what makes us different. They have different potentials or different voltage drops because they each have different resistance. They're not the same bulbs. They're a little bit different. Okay, so those are our two kind of ones that I wanted to go through. But if you go here, you'll see you got these. Okay, give those a go. Give them a try. First up, this one here. This is series. All I'm doing is messing with you. Really what this is this. This is the 30 ohms, and this is the 60 ohms. Now, we don't have to draw them like this. I like to redraw them this way so I can see the waterfall and talk about like my pump, and then it drops across them. And so that's oh, sorry, there's a third one here, 90. Sorry, guys. 3 in a row. Sorry about that. I didn't even see him down there. Sorry, buddy. Okay, this one, the current splits, so I have a parallel. Okay, so I could think of these two guys as parallel. But here's the key. If I have that current there, I do not have the current here. But what's the same in parallel? Voltage. Okay, so I could say I got 20 at 0.4 amps. And I have 40 ohms. Well, I don't know what it is over here, but I can do V equals IR for the left side. And so I get I, 0.4 times 20. 0.4 times 20 is 8 volts. Well, if it drops 8 volts here, these are parallel. So that's also 8 volts. This is also 8 volts. They're all 8 volts. And so parallels will have the same voltage. Okay. And then this happened, right? And then this happened. Gross, right? I want to give you these. These are, if you're like, dude, I got this. All right, let's do it. You ready? So this is like a game. I could, go back. It is like a game. Pen. So whenever you have two of the things, you do V equals IR. See how I have these two? The current's 2, the resistance is 400, so the potential, oh no, what just happened? So the potential, the voltage drop is 800. So it drops 800 volts. And here's the problem. They don't give you stuff anywhere else. And you have to decide, how do I use this information? Well, this is my junction. This is where it splits. Well, that 2 amps, I don't have 2 amps before. I have a combination before that point. So I don't know what's going on over here. I don't know what the current is. But here's what I do know. These two are in parallel. So if this is 800 volts, this is 800 volts. They're in parallel to each other. So now I can do V equals IR. I got 800 equals I times 700. I get the current is 8/7. I don't have a calculator, guys. No calculator. Okay, current of 8/7. Okay, so, 8/7. I'm supposed to put it by this guy. Okay, so at the junction, that means it's split. Well, what is my current then? I have 2 amps plus 8/7. So I get 2 and 8/7 amps right there. And this is where it gets tricky. What do I do here? Well, V equals IR. Look what you have. You have the total current of 2 and 8/7. Still don't have a calculator. And I got resistance of 100. So that means I can find my voltage drop is, oh boy, 3 1/7. So that's what? You know I don't know. It's whatever that is. we just say it's like 300-ish volts? This is not perfect. I know. 300. So now here's the question. If it was different color, so here it drops 300-ish volts. Here it drops 800 volts. So that means the battery did 300 plus 800 volts in the circuit. I'm realizing being yellow, it's going to disappear. So that means the battery was 1100 volts, because this one drops about 300 and this one drops about 800. And I have a lot of people every year, so this is hard not being in a class together. So I'd go around and we'd be talking, and a lot of people will say, oh, it's 800 plus 800 because I got two of them. No. When you have parallel, they're just the same, and it just drops the same across them, but it's still just 800. So 800 there plus 300 there, I get 1100. These are the tricky ones. Combinatoric circuits. If you keep going on in physics, or you keep going on, you're going to see these types of problems. So I just want to give you exposure. That's all I'm trying to do here, guys. It's a crazy times. I just want to get you exposed to circuits. So if I look at the next problem, it's a little bit different, right? I still have the current splitting here, but now I have information here. Well, if I look, this guy and this guy, they're not in parallel. They're in series. So what do they have the same in series? They have the same current. So if that's 2 amps, this is 2 amps. So that's 30 volts. This is 60 volts. That's a 30 up here, kids, not a 36. 30 and 60. So how much does it drop total? It drops 90. Well, if that drops 90, the guy who's parallel to him will also drop 90. So what does that mean my battery is? 90. Now, if I do V equals IR for this guy, I get 90 equals IR. I get a current of 1 amp. So here the current is 1 amp. Here the current is 2 amps. So when they recombine, I get 3 amps. Hey, I know this isn't perfect, but I just want to give you a start. I want to get you going. Try this one, okay? If you want me to check your answers, I'd be happy to, but just dive in, okay? So, hey, thanks for tuning in. Stay classy, Union.